ahead. Assistant facilitated decision making.
Alrighty. Yeah. Hi, everybody. I'm Saketh, and today I'm going to talk to you about a tool that I've been building with all these lovely collaborators. And we are trying to explore new ways to have AI agents help with decision making when building code for you. So, since their introduction, AI tools have changed how software is written today, and AI agents like Cursor, Claude Code, and Codex can now autonomously perform complex tasks that make large changes in a code base. Recently, several studies have explored how AI agents are used in practice, and they indicate that agents' capabilities come with mixed results. So at their best, they can help people achieve flow states, and they can improve their productivity, but these benefits also come with a lot of drawbacks. So developers are concerned about the quality of agent-generated code and consider these agents fast but flawed. And to mitigate these concerns, they often adopt a variety of different strategies. And one strategy that they use is to write extensive plans for the agent's implementation. So this approach has been formalized, as we were saying before, in tools like Plan Mode and Claude Code. And in this interaction mode, a user is prompting the agent to generate this plan, they're iterating with it until they're satisfied, and they're then asked to implement that plan. And there's a couple of things to note here. Throughout this process, programmers are making and encoding decisions into this plan, and that this communication is happening primarily through unstructured natural language and chat messages. So with Aporia, we're interested in making these implicit decisions first-class objects in a paradigm that we call decision-oriented programming. And within decision-oriented programming, first the user provides an initial goal, and the assistant is then going to ask the user questions about their goal. Sound familiar? These result in user decisions, and we're going to keep track of these in a decision bank. We can use this bank to show decisions to the users in a UI that they can then change if they'd like. And we can also use them to build a formal plan, which we can encode and code. I also just wanted to note here that tools like Claude, they occasionally ask questions to you while preparing a plan. But one of the big differences that our tool has is that it's centered around making these decisions first-class objects, and we view that as kind of different from all the other tools. So we see this approach as having three advantages. First, answering questions and seeing their decisions written down in front of them helps users clarify their thinking. Second, seeing their decisions gives them an affordance to be able to change how their decisions affect the code. And third, encoding these decisions in a formal plan clarifies exactly what they mean and gives the assistant a way to double check that that code is correct. So for our PLATEAU submission, we implemented decision-oriented programming for a specific goal, which is building custom generators for property-based testing. And we did this in a tool that we call Aporia. Just to quickly introduce property-based testing, also known as PBT, traditional unit testing checks code by testing individual hand-chosen inputs. And in PBT, we use a special program called a generator to produce a large number of random inputs. And these inputs are used to test properties that should hold under all conditions. So this is the kind of test you're going to see in the demo that I'm going to show you. But basically, we have a generator producing random lists of integers, and the code under test is a sorting function. And what this is saying is that if you sort something twice, you should still get the same list as sorting it once. So one major barrier to entry with PBT is that somebody has to write these generators. And this can get pretty complicated, especially when working with custom data structures that need their invariants maintained. So the task for our pilot was to write a generator that produces reasonable instances of data structures by some definition of reasonable. We think these kinds of tasks are interesting because they're open-ended. They don't really have any right answers, and this one requires an implicit understanding of the code base to decide like what is and isn't reasonable. So now that I've walked through our use case, I'd like to demo our tool for you. So this is a real open source project that lets you define and execute data processing workflows. And it has a generator here that produces structured data called named fields. And here's a test. You don't have to worry about the details too much. All you really need to know is that it's using the custom generator that I just showed you. What we're going to focus on is a generator that's a helper generator for this name generators field, and it's producing field names. It's producing instances of valid field names. It's supposed to produce realistic ones, but right now it's just producing random strings. So if we run the tests, we find that random strings won't work for this kind of test because an empty string is not a reasonable example of an identifier. So we're going to try to improve this with Aporia. This function over here is called a validity predicate, and it returns true if the generator is supposed to generate an instance, and it returns false if the generator shouldn't return. And this is going to be our formal plan. At the top of this plan, Aporia has asked me a couple of questions about what would be reasonable to generate. And this question looks interesting, so I'm going to click on it to see more details. So this is saying that a named tuple requires its fields to be valid identifiers, so we may want to add that requirement in our generator as well. Along with arguments, we always show a concrete example and some links to evidence inside the code base so you can see what parts of the code motivated the argument. I agree with this, so I'm just going to say yes and turn it into a decision. And as soon as I make a decision, I can see a summary on the right in the decisions panel. I can click on that to come back, and I can change my mind if I'd like, and that would eventually get reflected in a code change. Now that I've made the decision, I'm going to click here and update my formal plan and implement the generator. And it's updated our formal plan to show exactly what's meant by the decision I made. I can use this to clarify my understanding of the decision and as a tool to test the final generator. And now it's updated the generator to produce a field name with a regex. So that's Aporia. It asks us questions to elicit decisions, and we can then track and see these decisions, encode them into a formal plan, and that's going to help us translate to an implementation. So for the pilot that we submitted to PLATEAU, we conducted a within-subject study with the baseline using Claude Code and the treatment using Aporia. So the task here was the one that I just showed you, to recreate a custom strategy. And we asked folks to do these tasks and gave them semi-structured interviews with the baseline and after the Aporia task and the post-study interview as well. So we asked a couple of research questions. First, we asked how Aporia affected users' understanding of the generators they produced. And second, how it affected their understanding of the code base overall. Given our small sample size, it's really hard to form any conclusions, but I'd like to offer a couple of high-level observations, and I'm going to talk a little bit about a new iteration of this study that we're working on that I'd love to get your feedback on. So with respect to RQ1, participants expressed that they better understood their decisions, but they didn't necessarily better understand the code that the agent generated. And with respect to RQ2, participants generally spent more time looking at their code base with Aporia and more time looking at Claude Code's outputs when they were using the baseline. It's not clear whether this leads to a better understanding of the code base, but it's an interesting observation that we're hoping to build on another iteration of the study. So that's Aporia as submitted, but we are actually targeting WIST, which has a deadline at the end of the month. So I wanted to share some features and observations from our pilot and ask y'all, like, what kinds of questions would you like answered about how users work with these kinds of tools? So we've been experimenting with a new task for these user studies, which is implementing access control for a paper management system. And like the generator task, this one's designed to be open-ended, but involves a lot of nuanced decision-making around what different users can see and do based on their relationship to a paper. One feature that we support is the ability to set custom goals, so you're not restricted to working with custom generators. You can work with whatever. And we saw that with this, users expressed that they felt less pressure to have the goal fully spec'd out because Aporia is going to help them refine it. We also support using test suites as formal plans instead of just our validity predicate. An interesting observation here is that people didn't necessarily read all the details of the test suites. They felt like it was enough just to read these summaries up top that we gave them. But still somehow having the test suite there seemed to contribute to their feeling of like confidence in the code that was produced. And just to quickly wrap up, we also allow people to type in their own decisions because when working with a tool that's primarily driven by an agent asking you questions, people immediately turn around and say, hey, I had this idea, I want to type it in. But an interesting thing we saw here was that sometimes an agent would ask one question and then a person would look at it and decide something kind of tangential or unrelated and type that in themselves. So that's also an interesting observation from pilots. So I'm going to leave you with a couple of questions for discussion, but yeah, thanks for listening, and happy to answer any questions and get some feedback.
Any questions for Saketh?
Yes.
Can you expand a little more on how the decisions, once recorded in the bank, can get iterated over time?
Yeah, I mean, so we have something very simple right now because we're just trying to prove out the high-level idea. But basically, like, you can always click to come back and change your decision to say, like, yes or no if you want to invert it. But this form over here, which is something I didn't touch on, it allows you to, like, specify more details. So, like, maybe you want valid Python identifiers, but you don't want them to start with an underscore. Like, you could write that in there. And the idea is that, like, yeah, you can always, like, make subtle tweaks to the decision.
To tell more about why I'm asking, so my own experience has been that, you know, the first plan might be okay, but over time, like in writing the code, in conversation with the agent, like these decisions basically get invalidated without me knowing. Or I realize too late, that kind of thing.
100%. Yeah, so there's, in our pilots, we actually like just sort of bailed on this question and we gave the users a reset button so that they could start again. But like, I think that there's another question here, perhaps for another paper as well, around how you structure and organize these decisions. Like they're related, like oftentimes you'll have decisions where changing one changes another. And so it's like, how do you like build these things into a higher structure is like also something I'm very interested in. Yeah.
So in HCI, there's this principle called reflection and action, which is that I want a type feedback loop that gives me some sort of feedback about the decisions that I'm making, and that helps me sort of think about like the process that I'm undergoing and change my decisions and such. Mm-hmm. And so this is sort of doing the flat thing of like just at least show me the decision that I'm making, and that's, as you've seen, stimulates me to like sometimes make different decisions.
Yeah.
What would be really cool is I could like preview the consequences of my decisions at least a little bit. Like, do these decisions interact at all? Things like that. And I hypothesize that if you did this, that people would get a lot more value out of the decision making process.
100%. Yeah. Actually, something from our user studies that points in that direction. I think one of our participants said, like, I know what decisions I made, but I don't know if they were the right decisions. And and I think that's an important follow-up question to this. And yeah, I agree. I think that's interesting future work. Yes.
One thing that I wonder when I see this is maybe it could help reliability, because sometimes you code with the coding agent or something, and you're inside the session and you have this kind of state that's coming. So if you scrap everything and just give like the decisions to the coding agent, to what extent you think you can come back with a solution or have some kind of reliable way of getting the code given this set of decisions?
That's very interesting. I think the first thing that I think of in reaction to that is that if I made like 5 copies of like, assuming that the agent is like faithful to what I'm saying, if I made 5 copies of the code with the same decision, that would give me what I had not narrowed down. So like maybe I didn't say anything about like the color of the button in the UI, so it generates that 5 times, but I said where it should be, so it's like there. Yeah.
And when I was thinking about that, maybe these changes could be measured in some way or format.
Right.
What progress you're
That's very interesting. So it's kind of like, how reliably can you recreate this from the decisions as like a metric for like how well these decisions helped capture exactly what it was that they were trying to do. Okay, that's very cool. Thank you.
One more question?
I forgot what I was going to say. Sorry, I got distracted.
No worries. No worries.
All right, well, we have another coffee break now. Thank you, Saketh.